Okay, our next packet is P2, calculating probabilities using tree diagrams. Y'all, most, if not everything that we do in this particular packet can be done. It's a variation of what we've done in the previous packet, so the problems are very, very similar, but sometimes people can understand what's happening with a tree diagram better. So keep that in mind when you're doing it. It is, and you're going to see, I'm going to tell you again, it's all about the formulas, knowing how to use the formulas, and given enough information, all but one piece of information in the formula, you can solve the rest. Okay, so to start off with, I think y'all remember doing this earlier in your life, maybe in middle school or before, but let's go talk about it real quick. So 3 marbles, red, green, and blue, are placed in a bag and drawn out one at a time, and the marble is replaced after each draw. Okay, sometimes referred to as replacement. And I will say, when you're doing probability problems, y'all, if they don't tell you that it's replaced, then it is okay to assume it's not. So they're always going to tell you if something is replaced back. Okay, so we have a tree diagram for 2 draws. Every time you draw, so this is the first marble. When you draw the first marble, you've got a choice of 3 different ones. You could either get red, green, or blue. So you get that one. And then the next time you draw, if you draw red first, you put that marble back. You have the possibility of red, green, or blue. So this is showing you all the different possibilities or how to figure out what they are. So we are going to put them in a list and show the sample space. And the sample space, y'all, is what you get when you list all the possible outcomes of an event happening. Okay, so just going down the list in abbreviated format, I've got red, 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 green, red, blue. That's what I get. Red, 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 green, red, blue, which means I could draw red marble first and then second, red marble first and then green second, red marble first, then blue second. So continuing with that, I could have green, red, green, 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 blue, blue, red, blue, green, blue, blue. Okay, so what kind of problems do we have? The probability of drawing a red and green marble in 2 draws, because all of these are 2 draws, is, what is that probability? Before I fill that in, how many outcomes are there with a red and green marble? So if I look back, red and green, there's one red and green, there's another red and green, and there are no other red and green. So there are 2 outcomes with a red and green marble. And how many total outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of 9 outcomes, 2 of them are red and green, which means the probability of a red and green marble in 2 draws is 2/9. Okay? The probability of drawing at least 1 green marble. So at least 1 green marble is going to be, how many of these have at least 1? Now, I'm going to take this opportunity to point this out. At least 1, y'all, remember we just talked about the probability always adds up to 1. So you can go figure out how many of them, if it's at least 1, how many green marbles can you have? You can either have 0, wrong one, sorry. I can either have 0 green marbles, 1 green marble, or 2 green marbles. So if I want at least 1, that means I want that many. So I could take 1 minus the probability of no green marbles. That's the complement of the event, and we'll talk about that some more, but some people find that easier to figure things out. So you could go, if I think about it this way, how many of the outcomes have at least 1 green marble, or how many of them have none? How many of them have at least 1? Well, a green, 1, that one, 1, 2, 3, 4, 5. So 5 have at least 1 green marble. And remember, there's a total of 9. So that's 5/9 is what that's going to be. So the other way, what I was trying to point out to y'all is if I go and find out 0, because sometimes it's much easier to figure out this 1 than to figure out what's left. So I want to point this out to you. The probability of 0, there's 1 with no green marbles. So that's 1, 2, oh, that's a green. Sorry, 1, 2, 3, 4. So there are 4 of them, which of course you can figure out, but I'm just trying to point out to you again that sometimes it's easier to find what we call the complement of event instead of actually the event. Okay, now the really big thing about these tree diagrams is it can help you figure out conditional probability, which is what we were doing when we had the straight vertical line for information. So let's look at how this one is set up. We have consider the following scenario about guests at a wedding. 45% of the attendees are guests of the groom. Okay, so you go to the wedding, you have guests, and they can either be bride or a groom. So they write on the line what the probability that you're a guest of the bride is 55%. Probability that you're a guest of the groom is 45%. Now, of the attendees who are guests of the bride, 30% are male. Remember, this is that given thing. Okay, so that means of the bride, you can either be male or female. So of the bride, 30% are male. So what I really want to point out to you is on a tree diagram, this branch right here, all of these represent given probabilities. Okay. The groom's guests are 60% male. So you go down to the groom, male or female, there it is. So given you're a guest of the groom, the percent that you're male, or 60% of them will be male. Okay, so in a tree diagram, this branch represents the given. And how do you get an and statement? And this is coming from the formula, is that I'm going to multiply the two events together. And that will give me the and. So watch as we go through. The probability that a guest is female, given the person is a guest of the groom. So there's your notation. They didn't abbreviate it. Probability you're female, given a guest of the groom. Remember, given is just this number. So I just have to go to guest of the groom, probability of a female. So it's just straight up right there. No calculation involved. It's 0.4. Okay. Next one. Probability of randomly selecting a guest who is a guest of the bride and male is, okay, and remember, if I want and, I got to multiply two things together. So guest of the bride and male. So I'm going to go to the bride and male, and I'm going to multiply those two together. So guest of the bride is 0.55. Being the male is 0.3. When I multiply those together, I get my 3-place decimal. Okay. Now, one other thing that's really, really important, okay, and you're going to see this as you continue through, might even be on a lesson check. The probability that a guest at the wedding is male can be calculated by adding the probabilities of each case where a male is selected. So let's see if I can highlight. So if I'm trying to go find male, then I need to find this probability and this probability and add them together. So guest of the bride and male, we already figured that one out. That was 0.165 right here. Guest of the groom and male means I have to multiply 0.45 times 0.6, and that's going to give me 0.27. So the probability of male is adding those two together, which is 0.35. That is all there is to tree diagrams. So again, please email me or set up a Google Meet if you have any questions. Thank you so much, and y'all have a great day.